Hello viewers, concrete is the most widely used man-made construction material. It is obtained by mixing cement, water and aggregates both coarse and fine in required proportions either by mass or by volume. The proportions of ingredients can be converted from mass to volume and vice versa using bulk density of aggregates. Bulk density may be defined as the weight of aggregates required to fill a container of a given volume. Bulk density of aggregates can be calculated for loose weight or rodded weight. For determining the bulk density, the apparatus required includes weighing balance, either electronic or mechanical, tamping rod, straight edge, aggregate sample under test, and the observation sheet to record the readings. We also need cylindrical metal measure of 3 liter, 15 liters or 30 liters capacity according to the size of the coarsest particles of aggregate. For size of particle 4.75 mm and under, cylindrical metal measure of capacity 3 liters is used. For size of particle 4.7 mm to 40 mm, the cylindrical metal measure of capacity 15 liters is used. For size of particle 40 mm and above, the cylindrical metal measure of capacity 30 liters is used. To start the experiment, choose the metal measure of desired capacity depending upon the size of the aggregate. In this case, since the size of the aggregate is 20 mm, the metal measure of 15 liters capacity is used for the test. Take the empty weight of the metal measure. Now fill the measure loosely with the aggregate to overflowing by means of a scoop. The height of fall of aggregate should not exceed 5 cm from the top of the measure. Care should be taken to prevent the segregation of the particle sizes of the sample. The surface of the aggregate shall then be leveled with a straight edge. Now take the weight of the metal measure and loosely filled aggregates. this weight is 32.4 kilograms. Record this weight in the observation sheet. The net loose weight of the aggregates can be determined by subtracting the empty weight of metal measure from the combined weight of metal measure and aggregates. This comes out to be 32.4 minus 12.6, which is equal to 19.8 kilograms. The loose bulk density of coarse aggregate can be calculated as 19.8 kilograms divided by 15 liters, which is equal to 1.32 kilogram per liter. Take another set of readings and record it in the observation sheet. Average of two readings is taken as the final value. In this case, the average value of loose bulk density is 1.325 kilogram per liter. Now we shall determine the rodded bulk density of the coarse aggregates. To determine the rodded bulk density of this aggregate sample, the same metal measure of 15 liters capacity is used. For this, fill the metal measure about 1/3 full with thoroughly mixed coarse aggregate. Tamp the aggregates giving 25 strokes using the rounded end of the tamping rod. Now add the second layer of aggregate using similar quantity of aggregate and again tamp it giving 25 strokes. The aggregate shall finally be filled to overflowing and tamped 25 times. The surplus aggregate is struck off using the straight edge. Now weigh the metal measure filled with compacted aggregate. This weight is 34.4 kilograms. Record this weight in the observation sheet. The net weight of the aggregate in the measure is determined by subtracting the weight of the empty metal measure from the combined weight of the metal measure and rodded aggregates. Net weight of the aggregate shall be equal to 34.4 minus 12.6, which is equal to 21.8 kilograms. Rodded bulk density is calculated by dividing the weight of compacted aggregates, which is 21.8 kilograms, by the capacity of the metal measure, which is 15 liters. The rodded bulk density comes out to be 21.8 kilograms divided by 15 liters, which is equal to 1.45 kilogram per liter. Take another set of readings and record it in the observation sheet. Average of two readings is taken as the final value. The average value of the rodded bulk density in the present case is 1.455 kilogram per liter. The percentage voids in the aggregates can be calculated using the relation Gs minus R divided by Gs multiplied by 100, where Gs is the specific gravity of the aggregate and R is the loose bulk density of the aggregate. Assuming the specific gravity of 20 mm coarse aggregate as 2.65, the percentage of voids in aggregates can be calculated as 2.65 minus 1.325 divided by 2.65 multiplied by 100, which is equal to 50%. In the present video program, you have seen the apparatus and the experimental procedure to determine the loose and rodded bulk density of coarse aggregates, and also the percentage of voids in coarse aggregates. For calculating the voids in coarse aggregates, the aggregate to be used should be in dry condition. However, if only bulk density tests are to be conducted, then aggregate with given percentage of moisture should be used. The mention of the aggregate condition must be made while noting down the observations. I hope after having viewed this video program, you shall be able to perform this experiment in your laboratory. Thank you.